Thank you for being here. I'm going to run through a couple of the highlights of this code, talk about how we use it to crawl through the North Carolina Legislature website, perform a search, download bills, and ultimately analyze the text within those bills. So first things first, we have three different keys that we provide. First of all, the website to go find the bill search. Secondly, the keyword that we want to search on. In this case, we're using social justice, but this could be any topic. It could be healthcare. It could be Black Lives Matter. It could be the names of a legislator. Session keys, this is just which session of the assembly that we want to search under. So the current session we're in is 2021-22, last session 2019-2020, and so on. Now, this words to skip list is just, when we do our analysis, there's some basic words that we just don't care very much about because they're so common. For instance, date, or a, the, and an, as well as fiscal year. It's not going to tell us that much because it's just too common. Now, these are our XPaths. These are our places within the bill search form that we want to direct our Python to look at. So, for instance, when I think about this session, actually this is the search text as an example, I'm going to use the inspect. I used right-click there, and then hovered over the social justice. I'm going to inspect that. This section here, this input search, you can get the XPath, by right-clicking this, copying the XPath, and you'll see that that is going to look just like this, right? So I had my search input XPath here, and that matches exactly. So that's what XPaths are. That's how you're going to get some basic interaction using Selenium. Now, next, driver.get NC led search. That's just to get to this website. Timer to sleep. So this is just to give it 1 second to load. Next thing, we have it send our keys, right? So send the search keys to the form. And for instance, I can show you how that works here. If I delete this and then rerun this, you'll see it just filled in social justice for me, right? Automatically. Next thing is our retrieve bills function. So this is where it's actually going to go through all these 70 bills that we have resulting here and download them so that we can use them later. First thing it does is clears our download folder. So I have that currently pointing to this folder, which is full, right, because I already run the code. This will actually clear it out, right, because every time you run this, you want a fresh set. Then it actually loops through each of the bills, where you see this for I in list range 0 to the upper bound determined by the number of bills we have returned. And it loops through and it downloads each one of them, gathering information about it along the way. Scrolling down a little bit, first thing I want to look at is bills list I click. So as I said, it loops through, clicks through the bill by its index. So this is the 0th index, first index, second index, etc. Then it actually retrieves info about that bill. So let's say the first one we want to click into is this Senate Bill 537. The bill number we can see is right here. So that's where it's actually grabbing the bill number from. The bill name is right here. That's where it grabs the bill name from, right? So these XPaths correspond to these places, these elements on the web page. Next, it actually wants to look for two more things, attributes and sponsors. So you can see bill sponsors XPath, and next, bill attributes XPath. Now we do a little bit of cleaning along the way. For instance, we check for which sponsor on the bill was the primary, right? Because we can see that here. Bishop was the primary on this. And then during the bill attributes, one of the things it wants to look for is whether it's a public or local bill. Now, public bills just mean that they apply to 15 or more counties. Local bills apply to fewer than 15. And there's some nuance in there in terms of how the General Assembly treats those bills. But in any case, what we're doing is gathering information from this description web page. Now, having gotten all these things, the last thing it's going to do is the bill name XPath. It clicks it, right? So remember, this is the name. It's actually going to click that, which downloads the PDF for us. And since we set that above as a preference, it actually always downloads it here to this folder that we specified here in the bill downloads. Then having done all these things, it stores everything in a dict, which we're going to return to ourselves later at the end of the function so that we can do more analysis. And it navigates back. So when you do driver.back, it actually just clicks this button and goes back to our list of results. So in that way, we go through all the bills and we store them, both their text, both information about them. Now we run the function. You can see here it loops through all of our results, tells us it successfully downloads. Then we do this walk to make sure that we only want files. So rather than if that download folder had any extra folders inside of it, it removes those, gives us only the file names, and then it finally gives us the full file path by taking the download folder, which looks like this, right? We've specified this above, and appends to the end of it the name of the file. So we have a list of the files, and they look like this, right? So if we look at just the first one, there's the location of that first file that's in our list. Now scrolling down, the next thing that we want to do now that we have the bills themselves, we want to extract the information from them. So this PDF extractor is our overall function, and it leverages these two functions, text extractor and page compiler. So I'm going to go through these two first. Text extractor actually takes a bill, right? So path, it takes that one location of that PDF in our folder here. So it's actually going to go grab, for instance, House Bill 46, and it's going to read it using this module, and it's going to, for each page, it's going to get that page and then extract all the text from that page. And finally, it's going to return a dictionary where each page has a text aligned to that page number. Then the next function, all it does is take all those pages and convert them into one piece of text. So we start off by instantiating an empty piece of text here called PDF text, and then for each page, we append to that PDF text variable. So we just make this PDF text object bigger and bigger, appending each successive page to one big giant string. We want that one giant string because we're going to do analysis across all of the bills, across all the pages of every bill. Now, the PDF extractor, as I said, leverages those two functions. So first things first, we pass it all the file paths, and we ask it to run each of the functions. So you can see here, text extractor, page compiler. That gives us a result where we have full text, which is the text across all the bills, and a PDF dict, which is a dictionary with each of the bills contained separately. And each of those PDFs is pointed at a tuple in which we've contained the dict and the text, right? So for each bill, we have its entirety of its text stored, but we also have each of its pages as text stored. We're not actually going to end up using this page's individual text level in this analysis, but this sort of practice where you're storing each component as you create it is a good idea because you don't know where your analysis is going to take you. So it gives you a little more flexibility. Now finally, the PDF extractor function returns all that data to us as a tuple, which we later assign to variable names so that we can do some analysis. So skipping over this idea was to use a dictionary to shorten all the words in our results so that we could ignore words that were not actual proper English words. I have not implemented that yet, so we're going to skip that for now. A really basic but useful piece of text analysis you can do is to make a word cloud. This is literally just frequencies, right? Whichever words here are the largest are the ones that occur the most often in our bills. So, but it is a nice visual way where you can show that frequency. Stop words is a useful thing. Basically words we don't care about, right? So I'm going to skip up here, and if you see, remember at the top, all these words we just don't care about visualizing. This functionality, the stop words inside of the word cloud, allow us to not visualize those, which makes room for more relevant words. Some other things in here, we set some font sizes, set the number of words to visualize because we don't want it to be too cluttered, set the size of our PNG, right? So this is actually a PNG object and file, background color, right? So you can get more sophisticated with how you format this. But in any case, this gives us a nice image. And as you can see, unsurprisingly, General Assembly is a common word in North Carolina, section, right? So these are some words you'd expect to be across bills, but more relevantly, maybe human service is in here, public safety, right? So there are some words in here that tell us about what we're expecting, right, when we think about social policy and, social justice. Now, this is just saving the image to our folder, right? And we give it a string formatted as time so that we can store multiple of these images without overwriting each other. The next thing we want to do is, remember we grabbed all this information about the bill where we knew who its sponsors were and we knew the keywords, the attributes that have been assigned to this bill. This bill metadata section basically grabs that information and cleans it up. So firstly, the keywords, right? We look across all the bills and split all the bills by comma. So we take this and we set up each of them as an individual attribute, as an individual keyword. Then across all the bills, we use the set method, which basically just dedupes them, right? So probably almost all these bills have public as an attribute, because that means it's a public bill. We don't need to see public 70 times. We need to see it once. The set method just dedupes all those elements in the list. And then we just sort it here alphabetically. The next thing we're going to do is check for each of the bills if it has the keyword present in it. And eventually we store those as dict here. And then finally make a data frame. And you can see the data frame here looks like this. So we have each of the keywords we've found and the count that they were found, right? So health services are really relevant when emergency services. We can see these here stored. I'm going to hide that again. Now the same exact idea, but with sponsors. We find all the people who have sponsored a bill, and we store that in a data frame. Take a look at that. Excuse me. You can see Representatives Harrison and Farmer Butterfield, some other representatives and senators here had this many bills that they were sponsored of the 70. So Harrison with the most at 17. Now we're going to graph these as bar charts, really easy, important way to show frequency. We set some formatting here, right? So we're going to use Arial font, the weight and size, and all this good stuff. We're going to create a couple of figures. If you're new to using Matplotlib, there is some interesting ways that you have to set up figures and subplots within figures. I would encourage you to go look up in the documentation more info on that so that you can make sure your graphs are all beautiful and you can render as many of them as you want. Basically what I'll say is we only want to see 10 elements here, just because these graphs can get too cluttered if we see all the 70 or 90 or 100 different elements we found, most common sponsors, right? Let's just look at the top 10. Then we give it a title, we set some y-axis and some x-axis information, such as the size of the fonts. We choose to hide the spines for the top and the right and only leave them on the left and the bottom. You can see that here, right and top, setting those to not visible. And some other information such as the colorings of the lines. So scrolling down, basically you can see this nice clean graph where we can see the most commonly sponsored representatives about bills that matched our results. Same exact info here. This is the exact same formatting kind of code here, but instead this is to look at the keywords, right? So remember we saw the boards and local government were the two most frequent, public officials, education, health services, all of these getting more than 25 hits. So of 70 returned, 26, 27 it looks like here, up to about 34 you had these keywords associated. So almost half, or maybe more than half, had boards. More than a third had health services. So you can see these are really important topics related to our search to social justice. So that's the basics of using web scraping to go get the bills from the North Carolina General Assembly website. And it's also some basic things around text analysis, mostly using frequency, right? Finding which words are most frequent, both in the text of the bills themselves, for instance, which you can see here, and also within the attributes associated with the bill, right? And both are valuable. You can mine the data from within the PDF and get really sophisticated with how you do that. And you can also use what's given to you, the attributes, and learn important information there. And there's pros and benefits, pros and cons to all of it. So thank you very much. Thanks again for tuning in for Dave's Data Digest, and always feel free to reach out if you have a topic you want me to cover, and thank you.